The heating system operates exactly the opposite of the cooling system. An air conditioner supplies cool air indoors by exchanging heat and passing hot air outdoors. Conversely, a heat pump supplies warm air indoors by exchanging heat and passing cool air outdoors. A heat pump accomplishes its function by reversing the flow of the refrigerant. We supply the high-temperature, high-pressure refrigerant from the compressor to the evaporator rather than the condenser. The hot refrigerant sent to the evaporator will heat the evaporator coils. The evaporator fan will circulate air and pass it over the coils. Heat will transfer from the coils to the air, and this warm air will pass indoors and heat the home. The heat pump relies on three main control components to function: the reversing valve, second-stage thermostat bulb, and sequencing relay. Let's take a closer look at the roles of these control components. Recall that the heat pump reverses the flow of refrigerant in the HVAC system. The heat pump accomplishes this with the reversing valve. The reversing valve controls whether or not the system is in a heating or cooling mode of operation by changing the direction of refrigerant flow. In extremely cold climates, additional sources of heating are required to reach the desired temperatures. A stage thermostat bulb is a component in the thermometer that detects if the room's temperature cannot reach the set temperature. If we cannot reach the set temperature, the component gives a control signal to turn on the system's additional heating coils. Because these heating coils consume large amounts of electricity, a sequencing relay is used to help control power consumption. Sequencing relays control the sequence in which electric coils begin heating. The relay provides power to the heating coils one by one with a few seconds of delay in between. The sequencing relay makes the system energy efficient. We will now take a look at the sequence of operation in a heating pump. Setting the thermostat to the heating mode will trigger the reversing valve and compressor to pump high temperature and high pressure refrigerant to the evaporator. The high pressure, high temperature refrigerant will pass through the evaporator coils and exchange heat with the air that passes over them. The heated air will pass indoors, and the cooled refrigerant will continue to move throughout the system. The refrigerant will eventually return to the compressor, and the cycle will begin again. We will now take a look at control systems in gas heating systems. Recall that gas heating makes the use of burning fuel to produce heat. The heating process utilizes control components to perform its function. Gas heating relies on the following control components: thermostats, gas valves, pressure switches, igniters, and the furnace control board. We have already studied thermostats, valves, and pressure switches. The furnace control board controls all of the operations of the furnace. The control board operates on signals sent from the thermostat and temperature sensors. Suppose the room temperature is different than what is desired. The control board will either turn on or turn off the furnace. The control board is also responsible for controlling various functions. The control board handles gas valves, ignition, the blower, and the heat exchanger. The control board also performs safety checks, such as preventing gas leaks. Let's take a look at the flow of control. The thermostat receives a set temperature from the user and sends a control signal to the control board. The temperature sensor will read the room temperature and also send a signal to the control board. The board will interpret both of these signals and decide whether or not to start or stop the system. If the system needs to start, the control board will instruct the fuel valve to supply gas to the system. The control board will also send a signal to the igniter to start a flame. When the gas reaches the igniters, a fire will start, and the heating system will begin heating.